Hi and welcome to the first video on composite functions. This is 4.5 in your textbook. Now, the idea of composite functions is actually not too challenging. So a lot of the questions you'll be able to do, but there are some components of them that do get a little bit tricky. So you'll have to, I guess, watch very, very closely to make sure that you fully understand it. If you don't quite get it in this video, you can ask one of the other teachers at school there today, or you could just ask me in an email, or wait until I come back tomorrow to class. But composite functions, essentially what we're talking about is a function inside another function. Okay, so often they'll be written like this: f of g of x, or sometimes they might literally write, this, f of g of x, or other times I've seen this f o g. Fog, one function inside another function, so a function of another function. The actual algebra of it is quite straightforward, really quite simple, but sometimes defining whether the graph works or not, or the domains and ranges and all that sort of stuff can be a little bit tricky, but I'll get to that in just a little bit. So if f of x equals x squared and g of x equals e to the power of x, ignoring all of the domains and range, which is not always a wise thing to do, but let's just do that for the moment. If I want to find out what f of g of x is, what I simply do is I replace x with g of x, which is e to the power of x. And so I get e to the power of x squared, which turns into e to the power of 2x. And likewise over here, if I get g of f of x, I replace x with whatever f of x is. So in this case, I get e to the power of x squared. So the actual algebra of it is as simple as that every single time. It is not challenging. That's all you need to do. But I guess to know whether these graphs actually exist, that's where it gets a little bit tricky. So here's where I guess you really need to tune in. And I'll try and explain it a couple of different ways using lots of different examples. The first thing that I do is I type out, not type out, but I write out this little table here. I put domain and range up the top, and I put f of x and g of x, and I just type in, why do I keep saying type? I write in all of the things that exist. So my domain of f of x was all real numbers, my range was real numbers and 0. My domain was real numbers for g of x and real positive numbers for the range. Okay, and now I guess I want to ask the question, where does f of g of x exist? The reason I want to know this is because sometimes these graphs don't work everywhere. Sometimes you're actually trying to insert a part of a graph to another part that doesn't exist of another graph. Now I know that sounds a little bit tricky, but let me try and explain it to you. If for this to exist, for this function to actually work, then the range of the g of x, the inside, must be a subset of the domain of the outside. There's a bunch of reasons for that, but if that's all you know, if you just kind of rote learn this, then that's okay. The range of the inside needs to be a subset of the domain of the outside. And similarly, where does g of f of x exist? Well, the range of the inside needs to be a subset of the domain of the outside. Okay, so that's what I'm going to do now. I'm going to have a look at first I'm going to have a look at f of g of x, and I'm going to look at the range of the inside, which is g of x. My range is r plus. Does that fit inside the range of f of x? Well, yes, because r plus does fit inside r. It's a subset. Okay, this u on the side means it's a subset, or you can also have that as well, subset or equal to. So they can be the exact same thing, but r plus does fit into r because r is bigger than r plus. So this, what we can say is that this graph here, f of g of x, exists everywhere. And I'm also going to have a look at g of f of x. So g of f of x, I'm going to look at the range of f of x, the range of the middle, which is r plus and 0, and that is actually a subset, fits into the domain of g of x, which means that this graph also exists everywhere. So what I end up getting is f of g of x looks something like this, and g of f of x looks something like this. You're not really expected to be able to draw them like that because they are quite complicated, but that's what they look like in the end. But the important thing out of this is that they both exist everywhere, because this little rule here, the range of g of x is a subset of the domain of f of x. There's a good reason as to why that works, but maybe you just need to learn that for the moment. Okay, so that's what we're going to be doing for all, lots of different examples. We're going to be finding out whether the range of the inside is a subset of the domain of the outside. And if it is, then great, we can draw the graph, no problems. If it's not, then sometimes we have to make some amendments. Okay, so let me give you another example. F of x equals cos x, g of x equals e to the power of x. Again, I'm going to put in my domain and my range, and I get the domain of a cos graph is all real numbers, but the range is -1 to 1. The domain of e to the power of x is r, and the range is r plus. So I ask myself, is the range of, if I want to find out what g of f of x is the domain of the inside, f of x, a subset of the domain of the outside? Yes. So therefore I can say that e to the power of cos x is defined everywhere. Okay, I can actually draw the graph. Defined meaning just, it's possible, I can draw the graph. Now, is the other one true? Does the range of g of x, is that a subset of the domain of f of x? Well, r plus does fit into r, so therefore I can say that this graph is defined. So I could go ahead and draw this graph and have no restrictions on it whatsoever. I would just be able to draw it on my calculator. Okay, let's have a look at another example. Absolute value of x and log e of x. So I get, I put my table up and I get f of x equals all real numbers, and my range is x is greater than or equal to 0. For my domain for my g of x is x is greater than 0, and my range is r plus. So I ask myself the question, does g of f of x exist? So is the range of f of x a subset of the domain of g of x? Now, does x is greater than or equal to 0 fit into x is greater than 0? I can tell you no, because that one includes 0, but that one doesn't include 0. So this graph here is not defined. I'm not able to draw it, unless I make some alterations, which I can show you in just a little bit. But that graph doesn't actually exist for all of the times that I want it to exist. So what I can do is I can have a look at the other example. I can say, well, what about f of g of x? And I find out my range is exactly the same as my domain, so therefore that f of g of x is defined everywhere. I can draw this graph with no limitations or restrictions. So I guess the question that I do want to ask is, this one up here that doesn't work, is there a time that it does work? And the answer to that is actually yes. And so I guess I want to ask the question, what is the domain of f of g of x, or any of these composite functions? What is the possible domain that exists? Now, if the graph is defined, like most of the ones that I've seen, if the range of the middle is a subset of the domain of the outside, then I can say, if that's true, then I can just say that the domain of the new graph will be the domain of the inside graph. Okay, so for this example here, the domain of g of x will be the domain of the total, the composite function. If I go back up a little bit further, I can say that the domain of g of x will be the domain of f of g of x. The domain of f of x will be the domain of g of f of x. Okay, because they're defined with no restrictions, I can just say that the domain of the inside is the domain of the total graph. If the graph is not defined, like the example that I had up here, then what I need to do is I actually need to change a couple of things. And this is where things can get very, very complicated. So what I might do is I might make another video with this here, so you can have a little bit of a break, get your thoughts. You can even probably start some of the early questions from the exercise of 4.5, just some of the algebra type questions before you get into the nitty gritty of whether they're defined or not defined, all that sort of stuff. But the next video I will look at when something isn't defined. I'm going to change it so that it can actually be defined. So thanks for watching.